So number 4, what volume of 0.12 molar Ba, and that's a misprint, should be BaOH2, is needed to neutralize, I'll put this over here, 12.2 milliliters of 0.25 molar HCl. So I think the mistake, or the, not even mistake, but the trouble that most people had with this was we were given the wrong reactants, so we didn't have a proper way to balance the equation. So it should have been BaOH2, because barium is in the second column, it's a +2, hydroxide's a -1, plus HCl, and you always get a water and a salt. So the H and the OH make the water. And some people get kind of worked up thinking too detailed. Well, if there's one H and there's 2 of those, just write water. And if you write HOH, it'll even be easier to balance. And then whatever's not in that water will be the salt. So the barium and the chloride. So BaCl. But chlorine is in group 17, it's a -1 charge. Barium's in group 2, it's a +2. So +2 -1, it should be BaCl2. Then it's going to be a matter of balancing. So if there's 2 chlorines there, now I've got 2 chlorines. I've also got 2 H's. Here I can treat H and OH as separate things. So if I have 2 H's there, I need 2 H's there. Now I have 2 OH's, 2 OH's, and I'm good. As far as where to start, with all these you're going to have 4 things usually. Volume of base, volume of acid, concentration of base, concentration of acid. We don't know the volume of our base. We know the concentration of our base. We know the volume of our acid and the concentration of our acid. So start with the one you know the most about. 12.2 milliliters of 0.25 molar HCl. And it will be less steps and less writing if you just write that in liters, either mentally or on the side. So that'd be 0.122 or 0.122? Liters of HCl. And I would write the HCl to make sure you don't lose track of which thing you're talking about. So now I'm at liters of HCl. I eventually want to get to liters of base, or even molarity of base, or moles of base. But I'm at liters of HCl. The only other thing I know about HCl besides the volume is the molarity. How many moles per liter? So that's my way to get rid of liter. So if I had 1 liter of HCl and it was a 0.25 molar solution, that would be 0.25 moles per that 1 liter. So 0.25 mole HCl. Now liters is gone. Oh, that's not what I wanted to do. So now I'm at moles of HCl, but I want to figure stuff out about the barium hydroxide. So I want to get from moles of acid to moles of base. So if I want to get rid of moles of acid, I'm going to put this on the bottom. And I should be able to relate to moles of the base. How do I do that? Equation, which has the mole ratio, where for every 1 of these, there are 2 of these. We could do something different with converting moles to molarity and liters within this sort of step-by-step thing, but I think it's easier to just take the moles out of that equation. So we would take 0.0122 times 0.25 times 1 divided by 2, and we would get
0.0015
moles of Ba OH2, which barely fit on there. But we're not asking for the number of moles, we're asking for the volume. That's where I like to go back to the definition of molarity. Well, molarity is the number of moles per liter. Well, now I have the number of moles. I was given the molarity. So 0.12 molar BaOH2 is equal to number of moles. I have that now. 0.0015 mole of BaOH2 per liter. So I'm solving for liters, and however you want to do that algebraically is up to you. Probably. Yeah. Yeah. I usually do things the long drawn out way instead of the super quick way. If you find out a super quick way, you can do that on your own. If you don't want one, then you can go the long drawn out way. So 0.0015 times 1 divided by 0.12. What is the I don't even remember what the answer was. 13 milliliters, so 0.013 liters.
Yeah.
Liters or 13 milliliters of BaOH2. And those were pretty similar to 1 through 3, so I'm guessing the hiccup was the balance equation. Yeah. Do you know a chemistry lab is like a good party? Some drop acid, some drop the base. Just thought I'd throw that in there. Making sure you're awake. Five, I can see why you had confusion, because we have to go back to using grams and some stuff that we haven't done for a while. Not only that, it's in milligrams, a 55.0 milligram sample. This specifically? Like with milligrams? Maybe. Milligram sample of AlOH3, that one's not a typo, is reacted with 0.200 molar HCl. How many milliliters of the acid are needed to neutralize? So, how many milliliters of this are needed to neutralize? So this is a little different. It's not 2 concentrations and 2 volumes. So we're going to have to think back to how this relates. Milligrams, we usually don't use milligrams. We're going to use grams, moles, milliliters, so, or liters. But let's say we want that in grams. How many grams is 55 milligrams? It is 0.055 grams. And that's actually going to be our starting point. So 0.055 grams of AlOH3. Ultimately, we want to figure out how many moles of stuff that is to react with the moles of our acid. How do you relate grams and moles? Why do you say that number? Oh, where would you get such a number? The periodic table, you would take the atomic masses on there to figure out how many grams a mole would be. So to figure out how many grams a mole of that stuff is, you take the mass of aluminum, 26.98, plus 3 oxygens, 16, 16, 16, plus 3 hydrogens, 1 and 1 and 1. And you get a mass of 78. So that means 78 grams of this stuff, AlOH3, which would be called what, by the way? Aluminum hydroxide, would be equal to 1 mole of aluminum hydroxide. So now I'm at moles of the base, and I want to get to moles of acid. I forgot to do a very important first step. I forgot to balance the equation. I know. I got so excited to do the stoic that I forgot to balance the equation. So it would be HCl plus AlOH3 yields water and salt. So I'll just put my water in there, and it's easy to balance that way, plus aluminum and chlorine. Aluminum is a +3. That's kind of an oddball over here. And then chlorine's a -1. So AlCl3. I've got 3 chlorines over here. I want 3 chlorines there, but now I have 3 H's. I want 3 H's here. Now I need 3 OH's, but there are 3 OH's, so we're good. Now I can get back to where I was. Mole ratio. So I was at moles of aluminum hydroxide. And I want to get to moles of HCl. So look at that balanced equation. It seems for every 3 of those, there's going to be 1 of those. And I think, since we're looking for milliliters, I'm going to do the same thing I did last time. I just want to get the moles of HCl, and then I'll use the definition of molarity to get it. So 0.055 times 1 times 3 divided by 78 is equal to 2.1 moles of HCl. There's an L in there somewhere. And the definition of molarity is moles per liter. And we're looking for liter. Is this where you said we should rearrange it first to make it easier, or were you talking about up here? So if you wanted to get liters by itself, really you could swap those two things. So liters is equal to moles over molarity. So 0.0021 moles over our molarity. Yeah, there we go. 0.200 big M should give us a number of liters, which was at that 404 one. I could. (106 milliliters or 7.6 milliliters. I'm thinking sig figs we should have that as 11. I think the book dropped the ball on that one. Oh, you're right. Duh. Good call. Thank you. AlOH3. So in converting this, I should have done that, so I didn't get myself confused.